for private customers and for governmental customers. And the other field is being aerospace and industrial products in fields like aerospace telematics, railways, power and control. The origins of the company were pretty humble. It was founded in '58 as a marine hydraulics company. Was consisted of maybe 5 employees and did the projects for German Navy. But in early 80s, Mrs. Christa Fuchs decided to buy the company and put it on a different track. Her husband happened to be an aerospace engineer. He decided to leave his that time company and join OHB, which changed from Otto Hydraulik Bremen to Orbital Hochtechnologie Bremen, so the high technologies for orbital projects. And throughout the years, the company managed to gain know-how and reputation in aerospace engineering and acquire many sophisticated projects. The rapid expansion based on acquisitions of other companies across Europe made us already a pan-European company. We have branches in Germany, in Italy, Sweden, Luxembourg, Belgium, and other places. Our expertise covers satellite design, manufacturing, and operations, data transmission and processing, design and development of scientific payloads, mostly for Earth observation, but also structures and harness for aerospace applications. The space segment of our business covers satellites for communications, Earth observation and reconnaissance, and navigation, but as well scientific projects with European Space Agency, NASA, and JAXA. We built a broad range of satellites, from small-scale payloads and small missions to large structures for the geostationary orbit. And we also are facilitating the transfer of technology to the industrial applications fields, like the control systems for railway power supply. The German part of the company is based on 2 locations. One of them is the original one in Bremen. We have a series of big clean rooms with ISO 8 and ISO 7 class of cleanness. And in these clean rooms, we are integrating the satellites. I would like to emphasize that we are not actually focusing on development of the smallest components of the satellite. We are thinking about ourselves as systems integrator. So we are trying to subcontract the development or buy off-the-shelf components, and then we are managing the whole engineering of the whole system, integration, testing, verification, and later we're also supporting the customers during launch, commissioning, and operations activities. The other location is Oberpfaffenhofen on the outskirts of Munich. This was formerly known as Kaiserterde, and this one also has big clean rooms with even better cleanness up to ISO 5. That's because this part of the company specializes in optical payloads for Earth observation and for reconnaissance. This is exemplary timeline of our project, but it's not exhaustive. Some of the projects are not appearing on one. So it started as very humble series of demonstrator missions, mostly scientific, and at some point we have managed to gain several big projects, one of them being Zarlupe. That's a synthetic aperture radar satellite constellation commissioned by the German military, and project on the Columbus module of the International Space Station, where we've been responsible for the onboard equipment racks and harness. These two projects gave us a good boost in prestige and recognition, and allowed us later to acquire even more complex and prestigious projects. Like, for example, the HISPASat that was launched this year, and I think it also covers partially Brazil. It's based on a SmallGEO platform developed by us for the European Space Agency. NMAP, it's an environmental mapping satellite for German government. Galileo Constellation, that's our flagship. We've been responsible for the full operational constellation of Galileo navigational system. Meteorological satellites, satellite relays, and again follow-ups for the reconnaissance projects. So this is again overview of the scale of satellites that we are building, from medium-sized Earth observation to small navigational satellites, again to big antenna and big reconnaissance satellites that take aperture radars, but also payloads for other missions and parts of the missions concerning human spaceflight for the International Space Station and for the Dream Chaser shuttle. Now I will quickly overview the biggest missions that we have already flown. The first one is the Galileo Constellation. So we've been tasked with being a prime contractor for the first operational constellation of 22 satellites for the Galileo navigational system, and it has become operational 1 year ago, and more of services are being deployed as we speak, with the last third batch of this generation being awarded to us a few months ago. The SmallGEO is an attempt to build smaller platforms for telecommunication for the geostationary orbit to make it more affordable to smaller customers who cannot afford the big platforms for other aerospace companies. The first launched was the HISPASat this year. At the end of development is the EDRS. This is a satellite relay for geostationary orbit. Also Heinrich Hertz, that's a German telecom satellite for the government and the military. And Electra, that's an approach to make a fully electrical propulsion satellite. It will not even have a chemical thrusters. It will have only ion thrusters, and this way even a small satellite will be able to carry much bigger payload. The MetalSat third generation, that's done for the EUMETSAT and European Space Agency. So we are building the new generation of meteorological satellite with new imaging modes that were not present in the previous missions. You can see that this is one of the biggest satellites. You can see the scale with a human being in the view, and this will be the first this type of satellite that will be 3-axis stabilized. NMAP, as I mentioned before, it's an environmental mapping satellite equipped with hyperspectral sensors for monitoring the Earth atmosphere and surface. It's been commissioned by German Space Agency, and it's also now at the end of development. Lupe, mentioned before, a kickstarting project for OHB that was commissioned by German military, constellation of synthetic aperture radars that allows German military to have a full view of any point on Earth with better than 1 meter resolution, regardless of weather, regardless if there are clouds, regardless if Saddam Hussein burns the oil and covers the city with smoke. everything will be still visible for the radar. This project has a successor, Zara. That's a next stage, and this one will be two receiver satellites and one two transmitter satellites and one data analysis satellite. It will improve even the capabilities of the previous generation. From the exploration and scientific projects, the biggest one is the ExoMars. You might have heard about it. The ExoMars 2016 was already launched, and the orbiter, the trace gas orbiter, has successfully entered orbit around Mars and is already measuring the trace gases like methane in its atmosphere. Sadly, the demonstrator for the descent module successfully entered the atmosphere but didn't land, it more like buried itself. But that was still a very good lesson learned. We are using the conclusions from this failure to improve the coming design for the follow-up, which will be a rover that will be landed on the surface of Mars in 2020. In the first mission, OHB was responsible for the core module of the trace gas orbiter. So we built the thermal and propulsion systems as well as a structure. For the follow-up, we are responsible for the whole carrier module. I would explain this in a moment, but also for parts of the payload of the rover itself. In the non-space segment, we have projects like Condor. This is an airborne surveillance and reconnaissance platform that is supposed to make it easier to be deployed in places where the infrastructure is pretty poor, but we still will need to have good coverage with video, remote sensing lasers, and synthetic aperture radars. As I mentioned before, that we are not developing our components, but that's not fully true. Some parts we are actually developing, especially for the ground support equipment and also for some payloads. So these are the examples of equipment developed in-house. It covers optics, electronics, and avionics, mechanisms. Also, we develop software and we simulate our systems and in their environments. This is very helpful for the integration phase and verification. So now about more in detail about the project that I'm taking care of, the ExoMars 2020. The whole program is a European Space Agency program where the lead has Italy, and it's consistent from two missions. The first being TGO, where Italy was responsible for the descent module, and France had the lead for the whole orbiter. In the current mission 2020, our company, so Germany, is responsible for the carrier module. The descent module is built by Russians with supervision from Italy, and the rover is built by British, also with supervision from Italy. Now, to explain what this, how this mission is composed, it's pretty complex structure. We have a rover that will be delivered to Mars, and to put it there, we have to have a lander. And when they are together, we call it lander platform composite. Then this has to be shielded during the entry, so it's put into another structure called the descent module. And then we have the descent module composite, and then this descent module cannot just travel like this through space. It needs some propulsion, it needs some power and communication. So then there is the carrier module. That's the exact thing that we are doing. We put this all together, and we have the spacecraft composite. And the full spacecraft composite looks like this, with the heat shield and housing for the descent module and the rover. And this part is the thing that will be dropped just before entry into atmosphere of Mars. It will disintegrate there. It carries only the things that are not necessary for descending and not necessarily on the surface of Mars. This way we can limit the weight that will be carried by the entry capsule and the parachutes. So it is pretty complex system with multiple modules connected to each other, and all of them are partially independent, but still require some contribution from another one. We have 3 different onboard computers, 3 different power control units, and thousands of discrete telecommand and telemetry lines. And that's exactly the thing that the company is dealing with, to manage all these interrelations, all these connections, while the elements of this system are subcontracted to other companies. And this is the block diagram for the carrier module itself. So I am responsible for the CRTU, that's the carrier module remote terminal. The idea for remote terminals is that you don't want to always have every input-output just directly on the onboard computer, because you would not control the harness properly, and it will be very, very big surface used for the connectors. Sometimes you use a 2-wire bus to distribute the connectors to other places in the satellite. So we hang on a communication bus with the onboard computer, but then all the IOs are coming from our side, not from the computer itself. And we are responsible for managing the telecommunication subsystem that will be responsible for controlling of the satellite on the way to Mars. And we also control the reaction system, the thrusters that will be correcting the attitude and correcting the trajectory of the satellite. And further, we house the GNC, so guidance, navigation, and control subsystems like the star tracker and fine sun sensor. We have the thermal control subsystem, power control, and here is our interface to the descent module. So these are all the services that we provide to the descent module on the way to Mars. And to show again how complex this is a visualization of the carrier module itself. And maybe it will be more clear if I show only the harness. There are kilometers of cables of different types going around the structure. Everything has to be properly designed, properly measured. So this is very, very sophisticated task to be done, and this is exactly in what the company specializes in, integrating all of this, making it work. So, as I mentioned at the beginning, I will have some opportunities for Brazilian students and young professionals. The company is hiring really a lot of people. The high expansion period didn't end. We are still building new, acquiring new projects. We need more employees. We are focusing on systems engineering, assembly, integration, and test, and software architecture. But these are not only ones. These are the most required now. We have opportunities for students in form of internships, working students, and master thesis or PhD dissertation. You could expect to be working in highly international environment. We have currently representatives of 36 nations, including some Brazilians. The environment is very young. The average age is 38. And we have a lot of programs for to include more women in the engineering area. The hierarchies in the company are flat, so this is also a very good thing. The thing that also distinguishes us from the competitors, the philosophy of work is a bit different. You are not tasked to only your single field. If you are a propulsion engineer, it doesn't mean that you have to do propulsion all your life. You can also help some of your colleagues in other fields. If you have some spare time and some expertise, you can learn from them. At any point, you can try to migrate to another field, and you can try to also migrate to another facility, to another country or another city. So the work time is flexible. You decide when you want to work, maybe except of already planned meetings. We support sport activities with co-financing. There are a lot of trainee programs, career path models. We support the relocation. If you are getting accepted, you will get financial support to move to our facility. And when you are already in the company, if you want to change the location you're working at, it's also possible. When you want to apply, you can use the website, and you should provide the cover letter and CV detailing also your academic record. You should state your availability and duration of the internship you would be interested in, and provide relevant certificates. There are currently several positions open in the fields of electrical propulsion, in the fields of software, thermal systems, AIT, and telecommunications, but these are those that are really needed. If you have some ideas, you are also welcome to search for our attention with your idea. You can say that you would like to perform a different type of master thesis or internship on a different subject, and ask if we are interested. And it's possible that there will be an employee that would like to help you. Thank you very much.
Thank you, Dr. Conrad. That was a very interesting talk, and I can tell you from a lot of people here, it's good to know that there are opportunities out there, especially on the space systems. So with that note, I would like to ask the audience if they have any questions. Come on, people. No questions. Okay, so I have a question. Let's say we have a few students wanting to apply to this. Do they just go to the website, or there are some people they should talk, or things like that? What is your suggestion?
So the thing that I have mentioned just before, we advise to go to the website, which lists the opportunities in all our locations. So in Germany, in Brussels, in Belgium, Luxembourg, Italy, and so on. And there you can see what is already available, and you are free to apply there. That's the normal way for any open position. But if you know somebody, like now you will know me.
Okay.
You can tell me, I have an idea. Do you know somebody else who maybe is interested in having a working student, or in helping me with my master thesis on this subject? And maybe I can find this person. So then anyone you would know in the company, you are free to send this, make an initiative, send it there. But also on the website, there is also additional field for the initiative application, where there's no open position, but you have your own idea. It's also possible through the website.
Oh, thank you very much, Dr. Conrad.